Okay, so we've talked about the commutative property, which deals with moving, talked about the associative property that deals with grouping, and we've talked about the distributive property. So again, if you have something like 3x and then x squared plus 8x, if you want to simplify that, then what you can do is distribute that to all of that. And if some of you are like, well, that's weird, why would we do that? Well, you've done that your entire childhood. 4 times 6, 24, and then this times this, right? And then you get your 144. So, or something simpler like 119 times 2, or 19, sorry, times 2 when you were a kid. This times this, right? 18, this times this, you get your 38. So when you multiply, you have distributed your entire life. So, but again, remember, when you multiply, things change, but then when you collect like terms, they don't. So like here, I would get 3x cubed, create something new, and then again, distribute that. I get what? 24x squared, because I'm creating something new. Now, if I was adding, like if I was distributing this guy, and then maybe say I'm distributing a negative here. So I would distribute this. Again, when I multiply, powers change, so I get new shapes. Here, I'm going to distribute that negative. So this has to, because I'm subtracting all of it. So distribute, distribute, distribute. And then again, now I can collect like terms. Positive cube, negative cube cancel out. I have an x squared, negative 4x squared. So now notice powers do not change because I'm just collecting like terms. 3x plus 3. And again, if that bothers you and you're like, well, that doesn't make any sense. Why do we have to do that with a negative? Why don't we just make the first thing negative? Well, again, it all goes back to your childhood. When you took 432, and I'll try to pick some nice numbers, 111, that's really 430 and then a 2, and you subtracted all of it. You subtracted the 200, you distributed that. So minus, you had 200 plus 10 plus 1, but you distribute that. And so you subtract the 200 from the 400, you subtract the 10 from the 30, and you subtract the 1 from the 2. I mean, that's how you were taught to subtract, that you have to subtract not just the 2, you got to subtract all of this. So again, if some things aren't making sense, remember variables are numbers. So all of this worked in elementary school, and it still should be working today, even if you have x's in there. All right, so one thing that is going to happen is you might have a binomial times a binomial. So remember, a binomial has 2 parts. Or you could even have a trinomial times a trinomial. So 3 parts times 3, or maybe even a binomial times a trinomial. So far we've only done the distributive with a monomial times, maybe a binomial or a trinomial. But so if you have some lists, FOIL is pretty famous from high school. It's an acronym for first, outside, inside, last. And a lot of people like this. It's okay. It doesn't always work, so I'm not a huge fan. So first would be these guys. And again, remember, when you multiply, powers change. Outside would be these guys. Inside would be these guys. And last would be the 2 and the 3, which is 6. Right? And so then you have to collect like terms. So you have x squared, there's no other. And then you have what? 3x and 2x, those are like terms. And when you combine them, you just get x's. Cats and cats make more cats. Okay? And then 6. And that is simplified. And that's FOIL, because you're multiplying the first, the outside, the inside, and then the last. All right, but there's some other methods that work all the time, which I like a little bit better. So one is the box method. So you have, what do you have? You have x plus 2 and x plus 3. And the box really helps you organize. So x times x, powers change when you multiply. 2 times x, 2x. 3 and x make 3x, and 2 times 3 is 6. And then when you collect like terms, they don't. And the nice thing is this kind of lines them up. So I get x squared, stays that way. 3x and 2x just make more x's, so 5x, and then 6. So we get the same answer, but it's not using that acronym. If you were great at FOIL in high school and you want to keep using it, great. But a lot of people weren't super great at it at high school. So, if you want to try something new, that's great as well. Again, if you're, why does the box work? Well, again, let's think about how you multiply a 2-digit number. I mean, you can even multiply this the way you did in high school, or elementary school, like 12 times 13. This times this, this times this, this times this, this times this. So 3 times 2 is 6. 3 times x is 3x, and everything's positive here. 2 times x is 2x. Here I'm going to line that up like, you know how you normally put a 0. So 2x, and then x times x is x squared, and powers change. And then you just add down. And again, powers don't change when you collect like terms. So this box is just taking like the 2 times the 3 part right there. 3 times the x is there, the 2 times the x is there, and then x times x. So again, this is how you multiplied in elementary school. It still works. So if you like foil, great. If you like the box, if you want to do old-fashioned, like how you multiply 2-digit numbers when you were a kid, all of those are great. There is another option. I did not get foil when I was in high school, and it all turned out okay. I was still able to major in math, and life worked on because it didn't make sense to me. What I did is I covered up this number with my hand, and then what I did is I distributed twice. So I said, well, I'm going to cover the 2 up with my finger, and then I'm going to distribute that and get x squared plus 3x. Okay, and then I'm going to cover up the other one with my finger, so I'll just, let's see, I'll use black. So I'd cover this one up with my finger, and then I would distribute that guy twice. So, because I got to multiply everything by x, and so if I cover this up with my finger, then I got to distribute the x, and then if I cover this up, I have to distribute my 2. And so if this is my 2, then I get 2x and what, 6? So then again, collect like terms, and I still get the same answer. So you have lots of options. I kind of like the box, but you do what you want. So if the problem with FOIL is it only works with first, outside, inside, last, which means you have to have a binomial times a binomial. So if you had something like this, like x plus 2 times x squared plus 8x plus 6, FOIL doesn't work, and because there's a first and outside, but there's no middle, there's no m in FOIL, it only works with a 2 and a 2. The nice thing about the boxes is it still works. So you can make a box that's 3 on one side and 2 on the other. So the box can do really big problems where FOIL is limited. So switch to the next page and try it out, see how it goes. Okay, so I'm going to do the box on these. You can do other methods, see how it goes. So let's see, x times x creates a new shape, x squared. A negative 2 times that is a negative 2x. Negative 8 times x is a negative 8x. And then a negative times a negative is a positive 16. So then when I add to collect like terms, powers do not change because I'm just counting. So debt and debt makes more debt, but they do not change shape. And then 16. If you do FOIL, you're going to get the same thing. If you cross this off or cover it and distribute that guy, and then you kind of erase that, and then you cross off the other guy, see, maybe, and distribute this guy, and collect like terms, you should get the same answer as well. So any of the methods I talked about earlier still work. All right, let me look at this one. I like the box because it works for really big things. So x times x squared makes it a different power because I'm creating new shapes. Down here, I'm multiplying by 1. That doesn't change anything. All right, so collect like terms. There's only one of those. Let's see. I have a positive 1, but I owe 1, so that would be negative. You could put a 1 there if you want. Negative 2x again with a 1 is a negative x, and again, a 1 wouldn't hurt, and then plus 1. And again, when I add these together and these together, powers don't change because I'm just collecting like terms. All right, now, the bottom ones is you're trying to undo the multiplication, and they're giving you parts of the box. So see if you can try to figure out like what would go on top here, what would go in here and here and here, and then let's see, here, 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 here. So you're kind of trying, it's like a puzzle. You have parts of it, but not all of it. So see if you can figure out the missing parts, and I'll be back in a second. Okay, so in this one, we know they multiplied to get these, so you have to kind of ask yourself, like, 3x times what gives me that? Well, 2 would give me the 6, and what? X squared would give me the x cubed, so I know that's right. Here I have a negative. There's no negative over here, so instead of plus, it's going to be minus. The 3's there, and the 3's there. I have an x, I need an x squared, so I need an x. So if I take a negative x and that, I would get negative 3. Yeah, so that's good. All right, and then here I have 15, so I know I need a 5 to get the 15, and I already have an x. So my answer is this. So what you're kind of doing there is you're undoing the multiplication. So here's this multiplication, the 3x times this, if I distribute that, should give me 6x cubed minus 3x 13x. Now, when we unmultiply, we call that factoring, because remember the word factor means multiplication. So when you go backwards to make it into a multiplication problem, we call it factoring. When we try to get the sides, or when we try to get the middle, that's multiplication or doing the distributive property or FOIL or whatever. All right, so here, how do I get these? Well, what do these have in common that must have been multiplied? So this has to be an x, because obviously I got an x squared. So then this must be an x too, because x and x make x squared. So then if this is an x, I need a 4 somehow, so this must be a positive 4. And then now that I got that, I can fill in 3 times x is 3x, and 4 times 3 is 12. So I can go back, and again, there has to be a add or something in there. So if it's negative, it's minus. If there's nothing, it's positive. So I know that x plus 3 and x plus 4 are my factors, and they give me an answer of x squared 7x. Again, powers don't change when you're collecting like terms, 12. All right, so if you didn't figure this one out yet, give it pause, give it a try, and then we'll come back and do it together. All right, so let's look at this one. So again, it's kind of like a puzzle. We have parts of the pieces, but not all. The nice thing is we have both of these. So 2x times 1 is 2x, so that's good. I know that. Let's see, I know this is 1, so to get a 5, I must have had a 5 up here. And of course, it'd have to be positive 5 because there has to be add or subtract in between. Let's see what else. Well, for this to be x squared and I have a 1, this must have been x squared because x squared times 1 is x squared. And again, there has to be some type of symbol in between there, and there's no negative, so plus. So now I know the top, so now I can multiply x squared times x is x cubed. 5 times x is 5x. So again, what are my factors? The things being multiplied are my x plus 1 and my x squared plus 2x plus 5. And the answer, the product, is this guy in here. So x cubed, but I need to collect like terms. So these two together would be what? 3x squared. Oopsie. Guess maybe a pen would be nice. And then these two together would be positive 7x, because again, there's no symbol, so they're both positive. So you need plus in between. And then I have what? A 5? There we go. So these are what we call factors, and this is the product after you multiply it all out. All right, so again, if you hate the box, some other options, again, would be even with a 3-digit, you can still do like multiplication like you learned as a kid. So even if you're like, how would I do that? Well, just like you did as a kid, 40x, that times that is 5x squared, which is in a different place value, and that is what? 5x cubed. So you could do that. That one you could do the distributive property, just normal, because you only have one thing, so you could just distribute. If you love the box, you can even do the box with one thing. You could put a 5x here, and then put your x squared and x and 8 up here, so that if you don't really want to distribute like this, you could do it in the box. So, I mean, there are tons of options here. You just got to figure out what works for you. All right, we're going to stop there, and I think that's it for now.